Welcome to Friday Fractions. It's part 7 now. Second last part now. We know this. So, go faster than me if you want to. Work with me if you want to. Let's get started with question 1. 3/9 plus 4/9. Still easy. You know I never take away easy questions just because we can do hard questions. Still need to make sure we can do these. So we know that 3/9 plus 4/9 is 7/9. Let's go on to question 2. 2/3 plus 1/12. Not as easy because the denominators are not the same. So I change what looks like the smallest denominator. What do I want on the bottom? 12, like the other fraction, 12ths. So you look at 3, what happens to 3 to get to 12? 3, 6, 9, 12, you times it by 4. So you times the top by 4 as well. 2 times 4 is 8. Turn it into an easy question and get the answer. We should be really good at this now. If you've been doing every part of this series, I'm sure you're brilliant at these now. On to question 3. The hardest version of these addition fraction questions. 4/5 plus 5/6. Problem is the denominators are not the same. If I change what looks like the smallest denominator, even though it's not really, I want 6, don't I? But how many 5s fit into 6? 5, 10, 15, 20, it doesn't work. 5 doesn't fit equally into 6. So we can't use 6. You have to change both when this happens. What do you put on the bottom? Well, 5 times 6 is 30. So 30 is one of the numbers you could put on the bottom. There are other choices like 60, but 30 works best, I think. So you just look at each side, one side at a time. Starting on this side, what happens to 5 to get to 30? 5, 10, 15, 20, 25, 30. I times by 6. So times the top by 6 as well, and you get 24/30. Then on the other side, it will be something different. What happens to 6 to get to 30? 6 and 12, 18 and 24. Then 30 times it by 5. I'm counting on my fingers when I do this. You don't have to count on your fingers, but I tend to do that these days. So anyway, we times 6 by 5 to get to 30, so times 5 by 5 as well. 5 times 5 is 25. We turn it into an easy question. That's always the point. Turn it into a question when the denominators are the same, so you know the denominator is just going to be 30. Then you do 24 plus 25. You could do column addition for that if you need to. And you get 49/30. That's a top-heavy fraction. That's totally fine. But you might wish to change it into a mixed number, because if you have 30/30, you have a whole 1. We've got more than 30/30. I'll use 30 of those 49/30. If I use 30 of them to make a whole 1, I'll have 19 of them left. 1 and 19/30. 19 is a prime number, so unlikely. Yeah, we can't simplify that. It doesn't always happen like that, but if you have prime numbers in your fractions, it might be a clue they can't be simplified. Okay, that's question 3 done. Let's do question 4. Nice easy one. Just be careful, don't get the easy ones wrong. 4/9 minus 1/9. Make sure I'm doing the right sign, which is minus now. It's 3/9. Question 5. 3/4 minus 1/12. More difficult because the denominators are not the same. I change what looks like the smallest denominator. As I always say, it's not really. Can I get 4 to go into 12? 4, 8, 12, yes. Times it by 3 and I'll have 12ths on the bottom. So times the top by 3 as well and I'll have 9. So 9/12 take away 1/12. Don't need to tell you what that is. Make sure you do minus. And we'll move on to question 6. The last of the minus questions for a while. 4/10 minus 1/3. Well done if this is the 7th time you've done Friday fractions. That's amazing if you've done this every single week. You must be pretty amazing at fractions. So this time, I'll need to change both. 10 times 3 is 30. 30ths on the bottom will work. Squeeze that in wherever I can. 10 to get to 30 is times 3. 4 to get to whatever it's going to be, times it by 3 is 12. Does that make sense? 4 times 3 is 12. 10 times 3 is 30. 4 times 3 is 12. Times the top and the bottom by the same number. Do the same to the bottom as you do to the top, your teachers probably say. Over here, what do you do to 3 to get to 30? You times it by 10. So times the top by 10 as well, and you get that. 12, take away 10, that's 2. And we're dealing with 30ths. 2 30ths, that's fine. Could be simplified to 1/15th, couldn't it? But that would be fine on this question. And we're on times next. Easy stuff when we're on times. Do you know why it's easy? Because the denominators don't have to be the same. They are on this one, but they don't have to be. 3/4 of 3/4. I wonder what that's going to be. 9/12. 3 times 3 is 9. 4 times 4 is not 12. That wasn't making sense, and that's why. 4 times 4 is 16, isn't it? 9/16. I didn't think it'd be 9/12 because 9/12 is 3/4. And 3/4 of 3/4 is not going to be 3/4. So 9/16, can't simplify that. So that's it. Question 8. 7 times a half. Do you know what 7 times a half is? It's 3.5. It's going to be 3.5. Do this little trick. See what we get. It's 7 halves. Of course it's 7 halves because it's 7 times a half. 7 halves. 7 halves. There we are. But, like I did say, it is going to be 3.5. This answer is actually fine on this one. But it's going to be 3.5 when we make it into a mixed number, which you don't have to on this question. Because if you have 2 halves, you have a whole 1. We've got 2, 4, 6. We can get 3 whole 1s. Using 6 halves, we've got 1 half left. So it's 3.5. 7 halves is 3.5. Let's go on to question 9. 7/10 times 6. 7/10 times 6. So that would be 7 times 6 is 42. It will be 42/10, won't it? Trying to predict some of these. But I'll do the method as we always do. Yep, we get 42/10. That is fine on this question, but you could simplify it because you only need 10/10 to have a whole 1. And we can get 10, 20, 30, 40. Using 40 of those tenths, we can get 4 whole 1s. Using 40 of them, so leaving 2 of them left. 4 and 2/10, which a lot of you probably know. If you want to be totally as simple as you can get, is 4 and 1/5. Because you can half the 2 and half the 10. You get 4 and 1/5. For the answer, I probably have put 42/10. But all of these answers are actually correct on this one. This is not one that you currently have to simplify at the moment in the SATs. Number 10. What are we on now? Divide. So we need our KCF. Keep, change, flip. Keep, change, flip. Keep, change, flip. And then you can just do times. 1 times 4 is 4. 3 times 3 is 9. 4/9. That won't simplify it. That's done. 4/9. 11. 4/5 divided by 5. 4/5 shared between 5. What if that was 8/10 divided by 5? I think it's going to be 2/10. No, it's not. I'm not sure what this is. I was trying to do it in my head, but I don't think I know what this is. So let's do this. Let's do the KCF to find out what it is then. Keep, change, and flip. And we can do 4 times 1 is 4. 5 times 5 is 25. Is that right? 4/25. Oh yeah, because it was 4/5. It's going to get smaller. And 4/25 is 5 times smaller than that. So that makes sense. 4/25. I'm kind of teaching myself as I do these week after week to try and find a method for checking each question to see if it's right. Because when I look at 63 divided by 3/8, I don't have a clue what that is. I'm going to need to do a method for it, but I'm trying to work out ways of estimating the answers. Let's do this over 1, you know that. Keep, change, and flip. Okay, we've got some work to do here because we've got 63 times 8. 63 times 8, so I'm going to do a little column method. Don't be afraid to just do these little column methods. You'll probably find you're much quicker at doing this than sitting there for 30 seconds trying to do 63 times 8 in your head. You don't have to do everything in your head. So we get 504 on the top. I've just run out of space here. 1 times 3 is 3, and 3 on the bottom. That's a very, very top-heavy fraction, isn't it? One of the most top-heavy fractions you'll ever see. I have a feeling that will divide to make a whole number. So you know this line means divide, so you can do 504 divided by 3, another little method. Don't be afraid to do the little methods. And we get 166. It does actually make a whole number when you divide it. And that means you have to divide it. Because if the answer can be a whole number, then you've got to make it as a whole number. So you've got to simplify. And one way of simplifying is 504 divided by 3. So there's 166, and we're on question 13. Question 13 is normally totally easy. It's a little bit more difficult than usual today. 7 plus 8 fifths. It's a bit of a trick question. Because if you put them together, obviously you just get 7 and 8 fifths. But this, hopefully this is becoming a little bit famous to you now as something that the markers of the SATs don't like. They don't like a top-heavy fraction inside a mixed number. So you wouldn't get the points for this. You actually got to change it. You've got to use 5 of those fifths. We've got 8 of them. You've got to use 5 of them to get another whole 1 and go up to 8. If you use 5 of those 8, you'll have 3 of them left. So that one you would have to make 8 and 3 fifths. So a bit of a trick, because question 13 is normally totally easy, isn't it? If you've been doing this every week, you might remember that. On to question 14. 3 take away 1/9. 3 take away 1/9. There's loads of ways of doing this. It's actually, I can do it in my head now, maybe you can. It's going to be 2 and 8/9. Or, what I'm really doing in my head there is changing that into ninths. Well, I'm not really. What I'm doing in my head is I'm changing that into 2 and 9/9, which is something they wouldn't like in the SATs. It's worth the same as 3, isn't it? Because 9/9 is 1 and 2 is 2. 2 plus 1 is 3. So I'm changing it, in my head I'm changing it to that, because then I can easily take off 1/9 and it will be 2 and 8/9. I'm trying to show you some different methods on different weeks. And make you very aware that there are lots of ways of doing these things. So 2 and 8/9. Question 15. Oh, we've been doing these for a while. Simplify 45 fifths. Well, this line means divide, so you can do 45 divided by 5. It's 9 when you do 45 divided by 5, isn't it? Question 16. 47 divided by 5. It's going to be almost the same as the one above. It's going to be 9 and 2 fifths. Because 45 fifths, as we know from above, makes 9 whole ones, but we had 2 extra fifths. Can't make any more whole ones with 2 extra fifths, because we've only got 2 out of 5, not 5 out of 5. But we have 2 fifths. And question 17. A big number. You don't often see huge numbers when you're dealing with fractions. 3/4 of a million. Now, you might know, I learnt this myself just from looking at like football transfers when I was a boy, basically, because they deal with these kind of numbers a lot of the time. So I just know that 3/4 of a million is 750,000. But if you don't know, you can do divide by the bottom times by the top. So you do 1,000,000 divided by 4. 1,000,000 divided by 4. Now it looks like a very, very big bus stop, but it's actually a very easy bus stop once you actually do it. What's 1,000,000 divided by 4 then? 20, so that's 5, and then it's just zeros. So it's actually 250,000. Then you have to times that by the top. Okay, so what I did is I got the number, divided it by the bottom, get your answer and times it by the top. I can actually do this with what I call times tables in disguise. We don't need this 0 on the front, do we? I might get rid of that to clear things up a bit. Because I can do 25 times 3, which is 75, and then place the zeros, 4 zeros. And you get 750,000. 750,000. So 4/4 of a million would be the whole thing, would be 1,000,000. 3/4 is less, it's 750,000. On to the hardest 4. These are not my favourite 4, these. Sometimes these are really hard. Sometimes they're not too bad. 4 2/3 plus 2 9/10. First problem I'm noticing as I write it out is the denominators are not the same. So we'll sort that out in the way we do question 3 and question 6. 3 times 10 gets 30 on the bottom. If you're doing these questions, you know, you probably know what you're doing because they're quite difficult. So I'm going through them quite quickly now. So that 2/3 changed to 20/30ths. 9/10 will change to 27/30ths. Then I can add the big numbers. 4 plus 2 is 6. Add the 30ths and I get 47/30ths. And hopefully you notice that that is the kind of thing they don't like in the SATs, because they don't like a top-heavy fraction in a mixed number, do they? Said that loads of times. Maybe I'll keep saying it because it's important. So you have to use 30 of those 30ths to get up to 7 whole ones, which will leave you 17 left. 7 and 17/30ths. Time for question 19, isn't it? 19. 1 and 1/5. These questions, if you're ever trying to set a question for a younger brother and sister or one of your friends or something, or even yourself, if you're trying to set yourself a question, these are harder if the fraction in the first one is smaller than the fraction in the second one. And the first fraction is small because it's only 1 bit out of 5. The second fraction, you've got 8 bits out of 9, so it's nearly a whole one. This makes this quite difficult. What I'm going to do though, what am I going to do on this? I think I'm going to make the bottoms the same. That times by 9, so that's 9/45ths. That's times by 5, so that's 40/45ths. Then it doesn't work because you can't do 9/45ths take away 40/45ths. So I'm going to have to use the whole one, take the 45/45ths out of there, and plus the 9/45ths. So I get 54/45ths. So I've changed all of that into 54/45ths. Take away the 40/45ths and we'll be okay once we do that. Difficult questions, hope that makes sense. If not, just keep going. We've got another week of Friday fractions to keep practicing. 14/45ths we get for our final answer. And number 20 next. Six times 1 3/4. Can we do this in our head? What's 6 times 1 is 6. What's 6 times 3/4? That'll be 18/4. That'll be 4.5, I think. I think it's going to be 10.5, but I'm not confident enough. Anyway, 6 times 1 is 6. I'm just going to note that down. Done that bit, haven't I? Now 6 times 3/4. Well, 6 times... You can do 6 times 3/4 like this if you need to, can't you? 6 times 3 is 18. 1 times 4 is 4. So it's 18/4. So we have 6 and 18/4. Yet again, we have a mixed number with a top-heavy fraction in it, which we don't want. We're going to have to sort out the top-heavy fraction. 4, 8, 12, 16. We can get 4 more whole ones, taking our whole ones up to 10. Using 16 of those, leaving 2 of those behind. So I can change 6 and 18/4 into 10 and 2/4. Which is actually okay because it's not a top-heavy fraction, so I think that would be okay. They change their mind in people who make the SATs. Each year they might have made it different. Might make it more strict on the simplifying. If you want it totally simplified, 2/4 is the same as a half, isn't it? You have a circle, half is the same. Half, like the pink bit, is the same as 2/4. Pink bit is 2/4, isn't it? So 10.5 is our final answer. On to the last question. 3.5 divided by 5. Oh, what's this? What's this? So let's say it was 3.5 divided by 10. 3.5 divided by 10 is 0.35. I think it's 7/10. Let's see. If you need a challenge, that might be a good way of challenging yourself. Try and get the answer before you actually do the workings. Let's see if it's 7/10. So what am I going to do with this? I'm going to change this all into halves. 3.5 is 7 halves. 2 halves is 1 whole. 4 halves is 2 wholes. 6 halves is 3 wholes. And an extra half is 3.5. Yes. So now I can do KCF. Keep, change, flip. 7 times 1 is 7. 2 times 5 is 10. Yeah, it is 7/10. So that was my estimate. I would definitely recommend that if you're able to do these in your head sometimes. You still do them on paper. That looks a bit crazy, all that, doesn't it? That looks like difficult maths when you look at it like that. But anyway, we've got the answer, 7/10. So let's have a look at all the answers. 7/10 and everything else. Pause here if you need to do all your marking. Let your teachers know how you got on, and I'll see you again for one last episode next week.